Imagine a time before Earth, before the Sun, before even our solar system. Billions of years ago, our cosmic neighborhood was a vast, swirling cloud of dust and gas. This cloud, called a nebula, was the raw material from which our planet, and indeed our entire solar system, would eventually form. Within this swirling nebula, gravity was the architect of the cosmos. Minute particles of dust and atoms of gas, drawn together by this invisible force, began to clump together. These clumps, over eons, grew larger and larger, their gravitational pull increasing with their size. The nebula, once a dispersed cloud, began to coalesce, slowly at first, then with increasing speed and intensity. As more and more matter was drawn inwards, the center of the nebula grew denser and hotter. This region, destined to become our sun, glowed with increasing brilliance, a nascent star in the process of being born. As the sun ignited at the heart of the nebula, its powerful gravity continued to shape the surrounding material. Dust grains, drawn together by electrostatic forces, formed larger and larger clumps. These clumps, in turn, attracted more dust and gas, growing into kilometer-sized objects called planetesimals. These planetesimals, the building blocks of planets, orbited the newborn sun in a chaotic and crowded disk. Collisions were frequent, merging planetesimals into even larger objects. In the inner solar system, closer to the sun, temperatures were high, and only rocky materials could withstand the intense heat. It was here that Earth, along with its rocky neighbors Mercury, Venus, and Mars, began to take shape. Within the swirling disk of the early solar system, one particular region, roughly 93 million miles from the Sun, saw the coalescence of a particularly large planetesimal. This object, destined to become our Earth, continued to grow, its gravitational pull attracting more and more material from the surrounding disk. Collisions with other planetesimals, some small, some massive, added to its growing bulk. One significant impact involved a Mars-sized object called Theia, forming a ring of debris around the young Earth. This debris coalesced under its own gravity, eventually forming our moon. As Earth grew larger, its gravity became stronger, pulling in even more planetesimals and clearing its orbital path. Section 4. A Molten Inferno, Earth's Early Years. The early Earth was a hellish place, a far cry from the life-sustaining planet we know today. Its surface, bombarded by asteroids and comets, was a churning ocean of magma, heated to thousands of degrees. The atmosphere was a toxic mix of gases, spewed from the planet's interior by volcanic eruptions. Within Earth's molten interior, a process called differentiation began to occur. Denser materials, such as iron and nickel, sank towards the center of the planet, forming the Earth's core. Lighter materials, such as silicates, rose to the surface, forming the Earth's mantle. As the early Earth cooled, its surface began to solidify, forming a thin, brittle crust. This crust was constantly being broken and reformed by volcanic eruptions and asteroid impacts. Section 5. A crust forms, the solidification of Earth's surface. Over millions of years, the bombardment of asteroids and comets began to subside. The Earth, no longer subjected to such intense heat, began to cool more rapidly. As the planet's surface cooled, the magma below solidified, forming a more stable and permanent crust. Water vapor, released from the planet's interior by volcanic eruptions, condensed in the cooler atmosphere, forming clouds. Torrential rains, lasting for millennia, fell upon the young Earth, carving rivers and pooling in vast depressions on the planet's surface. The formation of these early oceans marked another turning point in Earth's history, setting the stage for the emergence of life. The early oceans absorbed carbon dioxide from the atmosphere, helping to cool the planet and create a more hospitable climate. Section 6. Oceans emerge, water's journey to Earth. The origin of Earth's water is a subject of ongoing scientific debate, but the prevailing theory suggests that it was delivered to the young planet by comets and asteroids. These icy bodies, remnants from the formation of the solar system, bombarded the Earth during its early history, depositing vast quantities of water on its surface. This water, initially trapped beneath the surface, was later released by volcanic eruptions, contributing to the formation of the early oceans. Water, with its unique properties, played a crucial role in regulating Earth's climate, shaping its surface, and providing a medium for the emergence and evolution of life. Understanding this story, the story of our planet's birth, gives us a deeper appreciation for the delicate balance of conditions that allowed life to emerge and thrive on Earth. It also reminds us of the interconnectedness of our planet with the rest of the cosmos, and the vastness of the universe in which we live.